Okay, so let's start in like few minutes. Maybe start by 6:05. Okay, I'll wait for few others to join. Any other session going on currently for you? Any
Yes, the Mad One TA session.
Mad 20 sessions? Okay. Apart from that, nothing is there, right?
Yes, sir.
Okay, fine.
Sir, in this session, can you tell a week 3 summary or light?
Yeah. Am I audible now? Okay, fine.
Yes.
Okay, just wait. Okay, I think week 1 to 3 revision sessions already been done, right? So, uh,
Yes, sir. So, sir, can you please briefly discuss about week three of week three?
why? What is the problem?
The question, sir.
What is covered in last session?
I have disjoined. I haven't like in the middle only. I have not connected with that session. So last time,
Okay.
yesterday.
I think
Sir,
last session we were just talking about all the relationships between the left null space, column space, the
Hmm.
orthogonality and stuff like that. But Sir was kind of he was solving people's doubts
Hmm.
over the like rather than doing a revision kind of a session.
Hmm.
So it was kind of half-assed. He covered the he asked everybody to do the first 2 weeks all by themselves,
Hmm.
and then he did the first week pretty properly, and in the third week he was just explaining the different concepts. That's it.
So you
So that's what happened.
all questions, huh? Questions on week 3 and
Yeah, we didn't pick up a lot of questions, sir. We did most of our questions from first week, but we didn't do as many questions from week 2 or 3.
okay, okay,
We
got it.
skipped that whole week too because he was like it was the revision for math two, so we completely skipped that part.
Okay. Okay, so what I'll do is I'll solve questions from mock, and while solving those questions, right, we'll get to know the concepts related to that. Maybe week 3, 4, 5 will be
Yeah.
the same thing. Anywhere is required, right? I'll just explain the concepts also. I'll be explaining the concepts related to like which are very important for tomorrow, right? The quiz. So
Yes, sir.
okay, getting like all the concepts done, I think will that take time again, and you don't have much time to again do all of this, right? So which are required concepts are there. Mostly, I'll be talking about that. Is that fine?
Sir, from week 1 to 5, sir, or just 4, 5?
Uh,
We really need that, sir.
I think 3, 4, 5 will be better, right? Like week 1 to 5, then
Yeah,
it,
sir.
it will go forever, I
Yes, sir. Most important concepts from week 3, 4, 5, sir.
Right, because see, it's like limited time. Generally, what happens is it will get extended, right? Sessions, and there is like capacity for me also to speak, right? So I cannot speak more than maybe 3, 3.5 hours, right? But I'll try to be in a brief, and I'll just cover only those concepts which are very much important for tomorrow's quiz. That's fine.
Yes, sir.
yes.
Sir, will exams have 17-ish questions too, similar to mock, because mock is taking a lot of time to solve.
It's kind of similar. See, like not 17 as like I don't know the exact numbers, but like 14 to 15 questions. I don't think that mock is. I don't know. Like if you are very clear with the concepts, I don't think you will take that much of time. But yeah, let us see that whether let okay let
Let's
let us
let's start
discuss.
the
Yeah, let us discuss first. And while discussing, right, if you have any doubts and if you think that okay I should be
let's not sir, sir let's keep this session as like a score booster session.
yes score boosters like that is fine but you should be able to at least like understand the concepts, right? If you see my point is if you understand the concepts, you probably will be able to solve the questions very easily. That is what my understanding is. But yeah, let us see what we can do more. Just give me a minute. Huh? Just give me a minute. I'll start the session. I had to take the call. Okay. Just give me a couple of minutes more. Okay, I hope all of you have understood the concepts, right? At least you know the concepts, so that yes, I don't know. My voice is fine, right? At least are you all of you are able to hear me properly?
Yeah, it's good now.
Fine, okay. And if you while solving the questions, right, you can actually participate into that, so that you will also understand that uh, you know it, right? So that is very important. Otherwise, there is no point in solving me the questions. You can tell me what is the approach we should solve while I'm solving. So that way your understanding will also be clear. And how much on an average you took the time for solving the questions? All of you have solved mock questions.
A few
Yes,
of
sir.
them. Yes, sir.
So how much time did you take to solve that questions? Approximately, it's like okay, fine, like 1 hour, 1.5 hours, 2 hours.
Sir, more than
Sir,
two
one
hours.
and a half hour.
But you guys
More
will
than
be,
1 hour, sir.
huh?
More than 2 hours.
More than 2 hours. I okay then there is some issue, right? There, because if
Because few calculations got wrong, and again I have to do
okay, okay.
complete.
So yeah, the on that front, right? Maybe I'll clarify you this that the calculations wouldn't be that difficult in actual exam, right? So mostly the exam will be some calculations will be there definitely, but mostly it will be like uh, understanding of the concepts. That is
Sir,
more.
how many questions will be there tomorrow?
You can
For
say
every...
that including all the subparts, right? Like let's say if you have one
Yes, sir.
question and it is having some subparts, so including all the subparts and all, I think like around uh, 14 to 15 questions will be there.
Okay, sir.
Okay, let me go through all of these questions. So and I think you need like week 3 concepts as well, right? As you said. Okay, let's try to solve this. Okay. Mm, let me go through this mock first. The first question I think no issues. Okay, maybe I'll take, if you have issues I'll take those questions from week 1 to later. At the end, if we get time, I think we should focus on the week 3, 4, 5 concepts, right? I think, and this mock does not contain week 5 questions, I guess. Or I don't know whether that new mock has been released for you. Okay, so this is a question, right? This is from I think week 3, right? uh, this is the matrix given to you, A and B. So the question is, B is a vector and A is the matrix. So Ax equals to B, whether this is consistent or not, right? So let us see the theory behind that first. Uh, when we say that uh, the system, okay, when we say the system, I don't know what, the system of, what is it? System of linear equations, right? uh, is consistent or not. Okay, let me do B. So this is Ax equals to B, right? When we say that this system of linear equations is consistent, okay, how will you say that system of linear equations? Suppose a1 x1 plus uh, a11, let's say a11 x1 plus a12 x2 equals to b1, a uh, a21 a a21 x1 plus a22 x2 equals to b2. uh, how this matrix will form for these two system of linear equations? What will be the matrix A? What size of matrix is this?
2 cross 2.
2 cross
2, right? So, and the elements of those matrices are A11,
A11, A12,
A12,
A21.
A21, and A22, right?
But sir, this matrix is 3 cross 3. Sorry, 3 cross 2.
Which one? The given.
The matrix
That is okay.
given in question is 3 cross 2.
Yeah, that is okay. So, okay. So you wanted me to show it like that, huh?
No, no, no. I thought you
No, no,
misread
no,
it.
I'm just,
Okay, no
in
problem.
general. I'm just talking about the concept related to that, and then
Okay,
we'll
okay.
solve the question so that
Can I solve the question now?
it will be refresher for you, right? So let's say, what do
Yes,
you
sir.
mean by that? If you are not earlier going through these concepts, I think I need to do some editing here, right? Okay, I don't know what is the issue here, but okay, let's do this. So this is the setting, right? Uh, so that will be your matrix A, that is your vector X, that is vector B. So this is what, vector of unknowns, right? Or uh, right, so we don't know this x1 x2, and we know only a and b, and that's how it is there. When we say that this system of linear equation is consistent, there are two criteria to it. What are those criteria?
rank of A equals to rank of augmented matrix.
So I'll say that uh, rank is denoted by, let's say, row. Okay, so rank of a should be equal to rank of a augmented b, and if that is there, if this is true, then we say that this matrix is consistent. And when we say it is not consistent, so rank of a is not equal to rank of a augmented b. So, and then then we call it as non-consistent or inconsistent matrix, right?
Sir, how will we solve the question?
Yeah, we'll see that. How will we solve? Everything will do that. So, right? I hope this is understandable. Do you know how
Yes.
to find out the rank of a matrix?
Yes, sir.
What do you do for finding out the rank?
Calculate RREM.
I think you don't need to calculate RREF.
REF also.
REF is enough to find out the uh,
Rank.
rank, right? So, right. Okay. So coming back to our question, the question is what? This matrix A, and basically this matrix A is what? Can you tell me the values? One of you tell me.
1 minus
Minus
1.
How are you saying that? Like row wise or column
Row
wise?
wise. Row wise.
Okay. One.
1 minus
Hmm.
1 1
Hmm.
1 2
One, two. And what is vector B?
113.
One, one. Okay. Is that fine? Okay. That's okay. So basically, this is the matrix. This is vector B, and now we'll have to find out its. And the question is what? The first question is, I think, whether this system of linear equation is consistent or not.
Yes,
Let
sir.
us say x is a vector which is of unknowns. Unknowns means, uh, or you can say unknowns, or sometimes it is called
X1, X2, X3.
variables. So how many unknowns are here, or variables are here?
2.
2, right? So this 2 should be equal to the number of columns of matrix A, right? I hope you understand that, because ax equals to b, when I wanted to do that, that has to so all of these equations has to be satisfied, right? So how this will look like, maybe for your understanding sake, I'll write it down. So this matrix A, so it will be like x1, uh, A is supposed to be, and here it is x1 minus x2 equal to 1, x1 plus x2 equal to 1, and x1 plus 2x2 equals to 3. Do you understand how these equations are coming in here? So I have just multiplied this here equals to this. So if you do it, you will get this kind of equation. So basically you will get three equations, right? 1, 2 and 3 equations. Okay, so there are multiple ways to solve this, but one of the ways we do it through linear algebra is, we'll have to find out the rank of A. So how to find out the rank of A? That is my preliminary question here. So now rank of A. The rank of A, try to find it out first. So you said we need to perform row REF, which is row echelon form. That is 1 minus 1 1 1 1 2. This is my matrix A. What should I do in row echelon form? This will be my pivot, right? Going to be my pivot, the pivot variable. Okay, after that, what should I do now? By if this is a pivot variable, then I'll have to make the this element. I'll draw maybe this element and this element. I need to make it as 0, right? That is the rule here, right? So what, how to make it 0 then? R2 changes to R2 minus R1, and R3 changes to R2 minus R1. So I'm doing all these two row operations simultaneously, because I think it is easier again to do this, right? So we'll do that. So here it is 1 0 0 minus 1, here 1 minus of minus 1, which is plus 2, and 2 minus of minus 1, which is 3. Is that fine? I hope it is fine.
Yes.
So
Yes, sir.
what will be my next pivot variable in this case?
2.
2, right? So this is going to be my pivot variable. Uh, I hope all of you know how to decide the pivot variables. And then what will be my next row operation?
So divide row 2 by 2.
R3.
Okay, we can do that also. So let's say R2 changes to R2 by 2. If you don't do also, that is fine. But generally people do, so that that will like it will make calculations easier, right? 0 1 0 3. What is the next step? R3 changes to R3 minus 3 times R2. Okay. Okay. I hope that is
Yes,
fine.
sir.
Okay, good. So, uh, so next, so after performing this row operation, what I'll get here is 1 minus 1 as it is, 0 1 0 and 0, right? So now you can see that it's a row echelon form, because you can see the staircase here, right? So that is my row echelon form. So okay, I have reached to this row echelon form. What is the rank now? By, so rank is the
2.
number of non-zero rows, right? So how many number of non-zero rows are here? So rank of A equals to 2, right? because this third row is all zeros. Second row and the first row is the non-zero row. So if you understand that part, then one thing is that rank of A is equals to 2. Now I need to find out what the rank of A augmented B. Fine. So first of all, uh, what is A augmented B matrix?
Sir, instead of this separate rank finding, can't we do only single, like for augmented one?
You can do it.
By that also we'll get to know.
Yes, yes, you can do it. So yeah, that is like one step you're skipping. That is fine. So in that way, your time will be like reduced, right? I just wanted to showcase you that what is rank of matter. That's why I did it. But that is the best way to do it. Fine. So what can you just tell me once again? One, I think 1, 2, right? And what is the augmented matrix here?
1, 1, 3.
One. Now I need to now do the same operations, right, to perform on this. So I'll just do it quickly. So R2 minus what is it? R1, R3 changes to R3 minus R1, right? So by considering this as a pivot variable, that case my matrix will be 1 minus 1 1. First row will be as it is. The second row will be changed as 0. Here it will be again 0. Here it is
2.
2. Here it is 3. Here what will happen? 1 minus 1 0, 3 minus 1 2. Is that correct? So the next operation was to make this element as 1, right? So R2 changes to R2 by 2. In that case, what will be 1 minus 1? Sorry. I hope this minus 1 is fine for you. Okay.
Yes, sir.
1. Here it is 0, 1, 0, and 0, 3, 2. Okay. Now the next part is R3 changes to R3 minus 3 R2. And if I do that, we have used like same steps, right? As we have done it previously, we'll have to do same here also. 0, 1, 0, 0, and 2 minus 0 is again 2. So yeah, so you can see that. Uh, so what is the rank of A? Only this portion. The rank of A is
2,
2,
sir.
and for rank of A augmented B
3.
is 3. And do these two ranks equal?
No, sir.
No. So that means this system of linear equation is not
Consistent.
Consistent.
Inconsistent.
right. Yeah. Uh, I hope you understand how to solve this problem, right? So,
Yes.
so the question to the question number 9 of this mock is a system AX equals to B is consistent? No, right? Okay.
So this one that if you scroll little up, if we say like that, let's say x and y. So here x minus y is equal to 1 and x plus
What is
y
Y
is equal,
here? What is Y here?
uh, just some unknown. Like if we take this equation like this, 1 and minus 1 is there and b is equal to like that.
Uh,
So system of linear equation, if we take it like that, so x minus y is equal to 1 and x plus y is equal to 1.
what?
So from there we can say, right, it is same time it is x plus y is equal to 1 and x minus y is equal to
Yeah.
1.
Yes.
So we can say it is not consistent.
Yes, you can say that, but generally it is like not very uh, easy, right? Like to say that it is possible or not. That way, you can say definitely one thing you can say is that uh, the null space, right, or not null space, the column space of A or B is not in the column space of A, that you can say, right? I hope you understand what I'm trying to say. So the span of A, if it is not like these two equations are not matching, then in that case definitely you can say that the span of B is not in the column space of A, and that way you can say that okay, rank might not be the same, and then the system is inconsistent. That's true. You are saying from these two equations, right? X minus y equal to 1 and x plus y equal to 1, this both at the same time cannot be true, and that is right. Whatever you are saying is right. Then definitely this system of linear equations will not be consistent, because then you will not get us the solution. What is the meaning of consistent and non-consistent is, or inconsistent is, when the system of linear equation is consistent, in that case you will get the solution, right? And solution means you'll get those unknowns x and y, correct?
Correct, correct.
And inconsistent is you will not get the solution. And definitely if you see these two equations, if we are not able to solve those equations simultaneously, then that means you are not able to get the solution, and that way it is inconsistent. That is correct.
Yeah, okay.
Okay, so see, it's kind of like seeing the same problem in different views, right? Like two different perspectives to the same problem. uh, Both the ways are correct. Okay. So the question number 10 is, using the least square approximation, find the length of a projection vector P of B onto the column space of A. Okay. Uh, okay. Basically, what do you want to find out here? Length of the projection vector. Okay. Okay. What is the projection vector in this case? I hope I think one of the sessions I have discussed it
You
here.
are.
Yeah, right. So maybe I'll try and show
P
you.
is the projecting vector and P is the projecting vector.
Let us say this is
That is B, and
actually what is happening is I've changed my laptop with the system, right? So Windows, actually I've put it into this laptop right now. Previously I used to use that Ubuntu system, so this pen and tab is not working properly actually today. But I hope my writing is like you are able to understand here.
Yes, sir, yes.
yeah, yeah, it's okay.
Right. So generally when we do this, like this was like projecting vector B onto A, right? And that we say that, let's say there is some proxy here, or the projection here, and if you multiply that with A, you'll get that vector, right? That is a
Yeah,
projection vector. But let us say if it is some space, let us say column space, right, which is spanned by, let's say, this plane. Okay. Right? So this is like there are two vectors of a matrix, a1 a2, and this plane is actually spanned by these two vectors a1 a2, and there is another vector b which is out of this plane, right? In that case, how to find out the solution? You project that vector onto this plane, right? And we say this as this projection as, let's say, p. But and let's say this is the projection vector p. Okay, let us say okay, I'll denote vectors by, let's say, bar. Okay, for understanding purpose, all these are vectors, right? A1 a2 and p bar is vector. So what is p bar is equals to basically it is like this, ax bar, right? Or ax hat. What all of this I'll tell you in a minute. X bar is what? These are the unknowns, right? Just two unknowns in this case. And what is A? Matrix A consists of A1, A2, right? These two vectors. This vector A1, this vector A2, and this will be your projection. Uh, I'll not go into the theory. If you wanted to see that theory, maybe you can
Let's
shift your.
follow the question now.
Right. So now the thing is, what is the solution to this problem? A transpose A exact equals to A transpose B. Is that fine? This solution to this problem, right? Our general solution will be this one for any uh, matrix or any. This is Ax equal to B, right? This is a system of like this. In this case, X will be your solution to this problem. But if your B is not in the column space of A, in that case, you will not be able to find out the solution. Then this is your approximate solution, right?
So just one doubt there.
Uh,
Can we straight away say that X hat is equal to A transpose B by A transpose A, or we have to take inverse if we take it
yes,
outside?
inverse, because these are the matrix, right? So you can say that this X hat will be equal to uh, A, sorry, A transpose A inverse A transpose B, right?
Correct.
And in vectors cases, it will be like A transpose A will be basically a scalar, right? Because that is the dot product between two vectors. That will be scalar. In that case, you can write like A transpose B upon uh, like divided by A transpose A or length of A. Both will be fine. But in this case, since this is the matrix, we cannot divide it by. We'll have to find out its inverse. So basically, this is your solution. What is asked here to find it out? The projection vector, right? And projection vector, as I said, it is Ax hat, which is A into A transpose A inverse plus B. Fine. Uh, okay.
So for to reach to the final calculation,
Hmm.
should we have this way A like A transpose A inverse this way, or is it okay to have left side right hand side and we go with the augmented matrix solution? What is the better approach?
I think augmented one is better one. So like it will be like little bit faster, right? So how will I? I'll tell you how you can do it, right? So let's solve for this. Uh, you can actually remember this part. A transpose A x hat equals to A transpose B. Think of this A transpose A as this part as some matrix, let's say K. Okay. So and A transpose B is some scalar C. So you are just kind of finding out the solution for K x hat equal to C. So how generally you solve this? You solve for this, no?
Excuse me, sir. In the above equation,
Uh,
X hat should be A transpose A whole inverse, right, sir?
yes. Sorry, that is a mistake.
Sir, I have a doubt.
Yes.
Sir, in this like projection, A where we use A into B upon norm of A and B vector, and where we use A
Vector,
transpose A.
vector. So if
Yeah, sir, I was having the same doubt, sir.
so
What is
if
the same?
uh, this is the vector, right? If you project one vector onto another vector, in that case, the projection will be like this: A transpose B upon A transpose A. That is your projection, x hat or x. Okay. In that case, x hat will be A transpose B divided by what is A transpose A? Basically, it is uh, norm of A square, right? Norm of A in the sense like length of that vector A square. And in case of matrix, I cannot write A transpose A into denominator. Why? Because that is when it is only scalar, that in that case only I can write it down. But in term when it is coming to the matrix, so when you wanted to project B onto some space, right? Subspace. In this case, it is let's say the column space of A, right? This A1, A2 are the vectors of uh, A, and that will span a column, that will span a space which is what column space of matrix A, and you are actually projecting the vector B onto that space spanned by columns of A. In that case, I'll say that the projection x hat will be A transpose B, basically you can see that it's like analogic, like if you see that analogy, it will be A transpose A here. But since this is also a matrix set, I cannot divide a matrix by its matrix. Then what should I do? I have to find out its inverse, and this is the correct way of writing it. It's like same, right? Kind of same. The only thing is I cannot divide a matrix by its by another matrix, and in this case, this is a matrix, this is a matrix. That's why this is a solution to your and that is your projection. So basically this projection will be uh, here exact, and when you multiply that projection with matrix A, that means this columns with columns of or vectors of this matrix A, in that case you will get a projection vector. This is called as a projection vector, right?
So these two understandable, but there is somewhere it is. I think in case of matrix, it is also taken as somewhere it is coming A in the equation. I'm not remembering exactly, but what you are showing here, it is both ultimately same, like the way we are presenting now.
Mm.
But somewhere I have seen that in that x hat or alpha hat, it also takes the actual matrix while calculation. It is like A into dot product of A transpose
Correct,
B by
correct.
yeah. Where is that it is A used and not used?
No, I think this is the one. I don't know what is it like. I don't see.
Where we in somewhere we use A into B upon no, A T B upon A T A and into the vector.
So in case of
That is
matrix,
just normal projection.
Same thing. It's like nothing. Okay, okay. I'll tell you one. Okay. There is
I
no
think
confusion basically. See, that is like manipulation of the terms. So let us say this is your vector B, right? This in case of vector, and this is vector A, right? When you project onto this, what will be the projection here? If you know that
yeah.
it is A
Mm,
transpose B is a projection, basically, right?
mm.
Okay. Then you normalize this by A transpose A. Okay, but this is a scalar. If you think of this like this is a scalar, right? The dot product between A and B is a scalar. The dot product between A and A is scalar, right? So whatever you get here, this quantity is a real value or a scalar, right? But you don't want this point, you want a vector here, right? And what is this vector? It is some scalar times this vector, right? Because this point is on that vector, right, somewhere, but it is not exactly the length of vector A. It is some portion of that vector A, and that some portion is this scalar. So this scalar times the vector A is actually a projection vector, right? Now if I wanted to find out the projection matrix, so what they will do here is you can write it is A transpose upon A transpose A times B. Sometimes it is written as like this, and this is actually a projection matrix. So this A transpose will be a symmetric matrix, correct na? I hope you
Yes.
understand that part.
And
And there is scalar.
this is the way of writing now.
So like what I'll do, I didn't do anything, right? This A, I have taken the like I have just multiplied this A vector A with A transpose. I have kept B outside, and uh, again the same quantity, right?
Same thing, na sir.
Yeah,
Both are the same results, na.
yeah, but when we calculate for matrix A, right? This case, right? Matrix case, then the calculations become little bit lengthy. But fine, eventually
We
it'll
can
be,
use the second formula, na.
you can use, but I think it's better to remember this one. This is like the understand, like this is like easier
So
one.
what you have shown earlier, I think that is easy to remember and no confusion. Huh? Using that also you can go to the solution,
Yes,
right?
yes.
Not
But
this
fine,
one, the earlier one.
It is easy
Yeah.
to remember. Second one is easy to remember, na.
this one
Sir, it is easy to remember.
I don't know. I
No,
think
the
this, See, this is very easy to remember, which I feel. Why, I'll tell you. Okay, maybe you can think of this, right?
Let's move to the next concept now.
Okay, this is Ax equal to B. I am analytic. Like if I think about the analogy, it's like A transpose A x hat equal to A transpose B. What I've done in this equation, I've just multiplied with A transpose on both the sides. Fine. And now if you wanted to find x hat, it will be like A transpose B upon, let's say, A transpose A, right? But this is not possible, and hence I'll have to write A transpose A inverse A transpose B. That is it.
So, sir, that is still possible in case of vector, but not possible for the matrix. So,
Yes,
but
yes,
yeah, we go to the solution in the same way, left hand side, what you have shown.
yes.
Okay.
See, I think this is easier to remember, but yeah, it's up to you. You can do like however you want to remember. You remember. Okay, let me do that for you. Okay, how to solve this? I will solve for A transpose A augmented A transpose B. Is that fine? Hmm? Uh,
Yeah, okay.
now what is A transpose? Can you tell me the values? One, I think minus one here. Uh, one, two, one,
1, 3.
three. And what is A? One, one, two, minus one, one, three. And what is B? So basically, I'm doing here is A transpose
Sir,
is A
sir, it's 1, 1, 1. A matrix is 1, 1, 1. Minus 1, 1, 2, sir.
one, 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 minus one, one, two, right?
Hmm. Yes.
Here is one, one, three, right? Okay. So let's find it out, right? Okay. So what will be? So now what are the dimensions of A transpose? It is 2 cross 3. This is 3 cross 2, right? This, obviously, so you'll get like 2 cross 2 matrix here, right? So A transpose A matrix will be a 2 cross 2 matrix. Now what are the values? Uh, and again, it should be a symmetric matrix. So the values are 3 here, 3, 2, uh, 2, and 1 plus 1, 2 plus 4, 6, right? And here it is, how much? 1 plus 1, 2 plus 3, 5. Uh, 5 here, and minus 1 plus 1, 0, and 6. Fine. Okay.
Correct. Yeah.
Okay. So now, how to solve this problem now? So basically,
Uh,
you will get two equations. You can actually do row operations, or you can solve it as it is. But I'll do the row operations. So think of this as maybe I can make it as uh,
the first one, 3, we can make 1.
2 by 3 and 5 by 3. That will be your pivot. Use that pivot to solve this. It is 0, like 2 times this, right? 6 minus 4 by 3, second point. So 18 minus 4 is 14 by 3, correct? And the next one is 6 minus 5 by 3. So basically it is 13 by 3. Is that fine? And now you solve it using the uh, let's say my approximate, so x hat was equal to, let's say, uh, m hat, and let's say c hat. Okay, is to some variables. In that case, what I'll get, two equations I should get. One equation will be, let's say, m hat plus 2 by 3 c hat equal to 5 by 3, and the second equation will be 14 by 3 c hat equals to 13 by 3.
Sir, in the last row, the 13 by 3, it should be like 6 minus 15 by 3, right, sir? 6
Uh,
minus 10 by 3, sorry.
oh, sorry, sorry. Okay, I think what is
Yeah.
it? 6 minus 2 by 3, right?
Uh,
Okay, what I did is two times I have removed, na? Correct only. Uh, I think okay, okay, got it, got it. Some one mistake here. Okay, here I think this is the mistake, right? It should be two times, right?
yes, sir.
So 6 minus 10 by 3, it should be 18 minus 10 then. 18 minus 10 is 8. 8 by 3. Correct. Is that fine now?
Yes, sir.
So in that case, it will be C hat will be your 8 by 14, which is uh,
4/7.
4 by 7. One minute. Okay. Uh, so C hat will be your 4 by 7. And if I plug in above, what will be the value of M hat? This is 5 by 3 minus 8 by how much? 21. Right. So it will be
21 there
25 minus
and
8, right? 27 by
7.
21. 21. Basically 9 by 7. Right?
Correct.
So that is these are the values for M hat and C hat. But then what else you need here? You don't need X hat, right? You need what? Projection vector, or rather the length of the projection vector, right? So what I said is the projection vector. And you'll have to multiply that, so it will be 1 1 1 minus 1 1 2, and these values are 9 by 7, and here it is 4 by 7. In that case, what we'll get here is, so it should be a, see now you think of a it is 2 3 cross 2 vector, and this
2
2
cross 1.
you will have
3
3.
cross 1.
So in that case, 9 minus 4 is 5 by 7. 9 plus 4 is 13 by 7, and 9 plus 8 is 17 by 7. So that will be your projection vector, right? And what will be the length of this projection vector?
Yeah, norm of the vector.
Square root of,
25 plus 169 plus.
you can do it later. Okay, so I'll just put it here, and then yes, right?
So, just
Yeah.
to avoid confusion, the way you have shown, Ax is equal to B, then we multiply A transpose both the side. If it is a vector, then we can divide. If it is a matrix, we cannot divide. Then we get to a solution of x hat or alpha hat.
Correct.
and from there we can directly place it in the p is equal to a x hat.
Hmm.
And in case both the case, whether it is a matrix or vector,
It will be same.
this will be same. Okay.
This will work out.
Yeah. Okay.
That's what I'm saying. That don't like remember all the things. Then it will be difficult, right? Think like simple. I think this is like very simplest, like it's very simplistic formula, right? Like you don't have to uh, like worry about it. If you know this all of you us know, right? Ax equal to b. Just think about like I need to multiply both the sides by a transpose, and now it will be like very easy, right? You can actually find out any equation from this basically. Okay, clear?
Sir, one doubt.
Hmm.
Sir, why you have taken M and C? M
Hey,
hat, C hat. In the place of that, you can take anything,
okay.
right? So
You can like yeah, you can actually basically you can take x hat, y hat, whatever. See, it's like I have already said this x hat is this vector of unknowns. That's why you can take anything. It's not like there is no restriction over it, right? Right? Okay.
yes, sir. Yes.
I hope that is clear to you here. Okay. Then next is how to find out the. So this is I think from week 4. So which of the following matrices have eigenvectors 2 1 2 1 minus 2 0 1 0 minus 1? Uh, I will not solve this problem as it is because I think this is like kind of a lengthy problem. I don't know, but I will tell you how to proceed for this. Right? What do you think about this problem?
A minus lambda is determinant equal to 0. With that we have to,
So this is what is
yeah.
So
this is called
firstly,
as eigen equation, right? This is your eigen equation. So basically, what it is saying is,
So
hmm,
I think for this question, solving for the just for the first option is fine. The second one is just the scalar of the first matrix. So first and if we solve for just first option, second option will be obvious, and remaining
hmm, hmm.
options cannot be correct.
Yeah. So first and second option like is kind of it's like multiple of scalar multiple of the, let's say it is
Uh,
2 times a, right? If I
Sir,
take
can two matrices have same eigenvectors but with different eigenvalues?
yes, this is the case, right? The first and second matrix. Okay, I'll tell you like how it can be done,
So
right?
finding the whole determinant and all, it's a very lengthy process. What we can do is we can just like post multiply with those eigenvectors, and we can check we are getting the scalar of that eigenvectors.
Correct. Yeah, yeah, that so that is like if you are very good at it, right? So I think you can by looking at it you can say that this easier, right? But I'll tell you. Okay, one more thing. I think somebody has asked me whether this will have the same eigenvectors, right?
So this someone mentioned no, the matrix 1 and 2. So basically 1 is the basis of the second matrix. But for other one we still need to try, right, to see the
Correct.
solution.
Correct. Correct.
Yeah.
So this is 2a x equals to 2 lambda x, right? Correct. This
Correct.
2a is
Mm.
another matrix, basically, right? Let us say bx equals to 2 lambda x. Uh, these are okay. In this case, you have the same eigenvector, right? Is the same eigenvector. Only difference is
So
what?
uh, we don't have to check for other options. If those are options have also have the same eigenvectors, that means they should be similar. So it's not possible, right?
Yes. Yes. But I think, see, the thing is, we don't know, right? Like for some other lambda, that
Mm,
eigenvector is possible, right?
yeah, if they should they have the same eigenvectors, then we should be able to get this matrices from the first matrix. So we can see that it's not possible. So we can just eliminate them.
Okay.
By forming by doing some row operations, we should get this matrix of the third option from the first matrix itself. Uh, they should be similar. Then only their eigenvalues will be same.
Mhm.
So based,
Correct.
uh, based
Correct.
on that, you can just eliminate
Yes, yes,
simply.
definitely. Yeah, yeah. Because if you get these eigenvectors for this matrix A, in that case only possibility is if the other matrix is scalar multiple of that, right? In that case only it is possible to get the same eigenvectors. Yes, yes, that's true, because set of eigenvectors will be like for any matrix the set of eigenvectors will be unique, right? Anyway, they will not change. I think yes, that's true. But you will have to check this possibility as well, right? A plus lambda I x equals to uh, let's say lambda 1 plus lambda times x. What does that mean? Okay, I think I'll write it down. So this is okay, right? This is correct. This is fine, right? Uh, let's say ax equals to lambda x, and what are the eigenvalues of cax lambda x, where c is some constant? In that case, what will be the does the eigenvector change in this case,
No.
right? And that means first and second matrix will be the same. Just give me 2 minutes, huh? Okay, is that fine? Till now is okay. So basically, if with the same eigenvalues, you will not get that. You know, so here only two options will be there: the first and second. Why? Because for the first eigenvector, for the first matrix A, these are the eigenvectors, right? How will you check
Yes.
that whether this is correct or not? You'll have to find it out basically. Uh, I hope all of you know how to find out the eigenvectors for this matrix. Or do I need to solve this?
Sir, you need to
Yes.
find it or you need to verify it, like
You can
multiplying by all three eigenvectors,
you
whether.
can do that. Yeah, you can do that also. So you can find it out, or you can just find it, like you can use this eigen equation. So you know that ax equals to lambda x,
Hmm.
right? Uh, in that case, what is the matrix A?
Options.
Can you tell me the matrix A?
It is 3, 2, 1.
Sir, I'm telling 3, 2, 4.
Row wise or column wise? You're saying?
Row wise, I'm saying.
Okay.
Uh,
3, 2, 4,
and then 202,
2, 0, 2,
and then 423.
4, 2, 3.
And eigenvector given is 212.
Let us say if I I just wanted to find out the like whether the first eigenvector is this eigenvector or not. What is it? 2,
2 1 2.
2, 1, 2, right? Okay. In that case, so what should I get it here? Another vector, right? Because 3 cross 3 multiplied with 3 cross 1, what I'll get? A 3
So
cross.
we'll get 3 cross 1.
That is
Cross one.
right. What are the values? Can you just quickly tell me?
So it is 6 plus 2 plus 8.
So that means 16
Yes.
plus
16, 8, 16.
16, 8, and
16.
8 plus 2, 10, 10 plus 6, 6, right? So can I write this vector, the sum, like some multiple of
Yes.
this vector, and
8
I
into 2, 1, 2.
8 times 2, 1, 2. Okay, 2, 1, 2. So can I say that it is some c times x1, or let's say not c times, let's say lambda 1 times. Okay. Sorry, sorry.
So 8 will be one of the eigenvalues.
Correct, correct. So your lambda 1 will be 8. Lambda 1 equals to 8. That is my eigenvalue. So the next thing is what to do. I'll just have to again use the same matrix 3, 2, 4,
You will have a second vector and find second
4, 2,
vector.
3. And what is the next eigenvector? So basically, you have to check for everyone, every eigenvector. What is the next eigenvector?
1
1
minus
1
2, 0.
Sorry,
1 minus 2 0.
1 minus 2, 0. Okay. And the multiplication of this will be what? Sorry.
Minus 1 to 0.
It's 1 to
Minus
0.
1 we can take common.
Minus 2.
No, minus 1 to 0.
Minus,
Minus would be taken out as common, then we will have that as eigenvalue.
yeah. So if I take minus 1 common, then I'll get
1 minus 2 0.
1 minus 2, 0. So your lambda 2 will be what? Is going to be minus 1.
Minus 1.
Lambda 2. Right? So that means definitely this eigenvector also a eigenvector of this matrix, right? Right? And again I'll have to do the same thing. It is 3, 2, 4, 2, 0, 2, 4, 2, 3. What is next eigenvector?
1 0 minus 1.
1, 0, minus 1.
So just asking one side question related to this. So this eigenvalues and eigenvectors, is it like we want to, in the real-time data set, we want to put some extreme condition? That's why we are learning this, like some data, if it is going through some extreme condition,
What
how
do you mean
it
by
will shape up.
no, I don't get it. Like,
So, I mean, let's say some asset class, if it is going through some extreme stress condition, so what will be the outcome? If we want to understand that, whether there is any application of this at that time. I'm just trying to correlate what is the relevance of this thing in real-time scenario.
of eigenvector or eigenvalue matrix you're saying?
Yes, yes, yes.
So in case of, see, I don't know in different areas, but in case of data science perspective, right, these eigenvalues are very important. Eigenvalues and eigendirections are very important. uh, why it is, I will tell you. So if you have learned about the dimensionality reduction, right, maybe not learned, I think you have the slightest idea about the dimensionality reduction technique, which was there in first week. I hope you remember that.
Yes, sir.
Correct, correct.
Okay.
But
So yeah. So what does that mean? If you have uh, variables, right? Dimensions, like, okay, this matrix will have how many dimensions? Three
uh,
dimensions, right?
three-dimensional.
Or because you have each feature or each of this variable, right? Or each, let's say, example, you'll have 3 dimensions. So if you have, but instead of that, in real world data, you have hundreds of features or thousands of features, right? In that case, it is difficult to do all of this linear algebra or apply all of this onto this that kind of matrix. Difficult in the sense, it will take much time or it is computationally expensive. In that case, what we do is you find out the eigen directions. Eigen directions means which one? This eigenvectors, right? And you what you do is you project all the data onto that direction, and you preserve, and you preserve only those eigen directions which will contain the maximum variance. And that way you don't need to, let's say 10,000 directions were there, instead of that, or 10,000 dimensions of there, instead of that we will be using, let's say 20 dimensions, which are, and these 20 dimensions are the eigenvectors. These eigenvectors are the okay, I think, see, that will come into the PCA case. That time anyway we are going to discuss, like I think it is week 7 or 8. I think week 7 is the PCA. In that case, in that week we'll be like discussing much about it. So there it will be very useful. So whenever you actually, whenever you any data, right, if you try to uh, showcase using the linear using the matrix, then all of these eigenvalues, eigenvectors will play an important role. So there are, like, it's not like only one case I have told you. If there are multiple ones, as this course progresses, right, I think you will go through machine learning techniques. The next course after this, you'll get the specific examples of it. So one of the examples is eigenfaces. You can search it online. So I think that is like a very important. So these eigenfaces, you can search it for your understanding. Maybe we'll talk about it later, maybe next week after, because this is anyway the revision session for the quiz, right?
Yeah, fine, no issue, sir. We
uh,
can
we
be
will
on the
we,
track.
Maybe
Yeah, yeah.
yeah.
maybe I will just give you one minute. I will tell you what exactly. For
Mhm.
example, if there is a 1,000 x 1,000 features, okay, 1,000 x 1,000, that much big matrix. If you want to save each feature, that one pixel is one, yeah, 1 byte of data considered, then you need 1,000 x 1,000 bytes. But when we are using eigenvector and eigenvalues, then instead of storing that much 1,000 x 1,000 data, you can just store only the eigenvector into one matrix. Okay, means only 1,000 values, and you can store the corresponding eigenvector for that, another 1,000 values. So it is 1,000 plus 1,000, 2,000 only. So instead of storing 1,000 into 1,000, you are just storing now 2,000. So that is that much information only needed for representing your data, instead of storing that 1,000 cross 1,000. So that's the use of this eigenvector and eigenvector.
And using that, we can still go back to the original.
Yes,
Yes,
right.
yes, you can reconstruct your actual.
Yeah, okay, sir. Yeah, we can proceed. Yeah.
There are multiple use cases for it. Okay, it's not like only limited to that. Even the current technologies which we are using, they are also based on that. So diagonalization of the matrix is the important topic, right, in our case. Okay, this question is related to diagonalization. This is very important one, as your point of view of your exam. So tomorrow this concept might be very useful. So just understand this very properly. So let the matrix A, which is in R D cross D, be diagonalizable then which of the following statements are true. So first of all, can any one of you tell me the matrix A is called diagonalizable when, or what are the conditions to be uh, diagonalized?
If we have an invertible matrix
Hmm.
S multiplied by the diagonal matrix to form the matrix A.
Okay, so yeah, so you can say that if any matrix A, if it is having n independent eigenvectors, right, eigenvectors in that case, and corresponding to it, like all lambdas are different, then I can say that that is diagonalizable. One more thing is that you can say that this matrix AS equals to, it should uh, there exists a diagonal matrix, right? This is a diagonal matrix. Diagonal is a diagonal matrix, right? And this is what? This is a matrix of
Eigenvector.
eigenvectors of A, right? right?
Yes, sir.
So S is what? S is the matrix which is formed by the n independent eigenvectors of A, correct? And that,
Arranging them as columns, it will
yes,
be formed.
yes, and you will find out a diagonal matrix lambda such that if I multiply this matrix A with this S matrix, you will get some diagonal matrix. So diagonalization means there exists some lambda, right? Lambda, or this is capital lambda basically. This lambda equals to what it will be then? Sinus is, right? There is exists some lambda here. So now the question here is, A must be symmetric. We can find a basis of eigenvectors of RD, and these are all options, right? Okay, can you tell me now what are the correct options? If A is diagonalizable,
Second and fourth, because the first and third option are true for orthogonally diagonalizable, which is not given.
correct. So A must be symmetric is not like hard and fast rule, right? If A is symmetric,
It's not a mandate.
correct. But if A is symmetric, does the matrix A is diagonalizable?
Yes.
Yes.
Yes, right? Is that correct?
Yes.
Yes, correct.
But the matrix to be diagonalizable, A need not be to be symmetric. The only condition that the A matrix A is diagonalizable is what? It should contain n independent eigenvectors. When I say n independent eigenvectors, what will be the what do you think? Like what should be its uh, dimensions for matrix A?
Such that
N
the
cross
S
N.
n
matrix will
cross
have
n.
same dimension.
Does it require to be a square matrix
Yes.
Yes.
Yes, yes.
Yes.
or no? If the matrix is not square, is it possible to get that? Uh,
No, we won't get
In
the
It won't be
that
possible.
case, it's
hmm?
not possible. In that case, that rank will be lower. No?
Correct. So you'll not get actually all the eigenvalues, right?
All the eigenvalues, yes.
So basically, A can be a square. A can be any square matrix. It need not be a symmetric matrix, and it should have what? N independent. Sorry. Okay. Writing here is not that good, but yeah. I'll- Okay. Should be. It can have n independent eigenvectors, right? And when we'll get the n independent eigenvectors, it will have all different eigenvalues, correct, right? And if the matrix A is having the same eigenvalues, in that case,
We'll have to check.
same eigenvalues, then it may have n independent eigenvectors,
Or
or
less.
it might not have.
It
But
may
if your
not.
eigenvalues are different, like all eigenvalues are different, in that case it is very sure that you'll get n independent eigenvectors. And if you get any n independent eigenvectors, in that case you can say that that matrix A is diagonalizable. So one thing is A should be a square matrix, and then you can proceed forward. One more thing is, if one of the eigenvalues is, let's say, 0, is it possible to get your and let's say other values, let's say if you matrix is having these eigenvalues 0, 1, 2, in that case can you tell me whether that matrix A is diagonalizable or not?
No.
Why not?
Zero is also unique, na? It's like if one. It's
Correct.
not.
So
Because the determinant itself will be zero and A will not be invertible.
but does diagonalizability dependent on determinant?
No.
No, right? So if you
No.
have different eigenvalues, then that means you definitely will get the three different eigenvectors, right? Because these three
Uh,
are the distinct eigenvalues.
Sir, what was
And
the question?
what I am saying is, let's say these are the eigenvalues of the lambdas, right? These are the eigenvalues of a matrix A. Is it possible that, or let's say that matrix A is diagonalizable or not? By looking at these eigenvalues, can you tell?
So then the case is like the vector will be zero only.
No,
Zero vector is only possible
it,
for the
it need
eigenvalue.
not be right. It need not be right. See, if the eigenvalue is zero, does that mean that it will have all?
Okay, yeah. So
No.
then the vector will be in the null space of matrix.
Yeah. Just give me a minute. Huh?
Hello.
Yes.
Is there a break then?
1 minute break.
Sir
Oh,
is excused.
Okay. I think yes. Where will be? I hope all of this clear. So now, yeah, you can tell me like then option A is not true in this context, right? A need not be symmetric. If it is symmetric, it's good.
Sir,
Definitely.
hi sir. I have a doubt in basis of eigenvector. Can you explain
Uh, okay.
what the meaning of basis?
What do you think of basis of matrix A? Any matrix A?
I have no idea.
We have to get to the row echelon form or reduced row echelon form. Wherever you get the pivot and element, map that back to the original matrix, and those will give you the basis. And if they answer, like, did you get it? What I'm saying?
No.
Okay, then start to explain.
Okay. I think I think you should know all of that, right? Like, if I started basis, like okay, basis is you can think of like okay, I'll tell you in layman term what is basis for anything. Like let's say if you have a matrix, right?
Hmm.
Uh, you should get those vectors which actually can like those minimum vectors. Let's say okay, uh,
Okay.
which
Hmm.
actually can get me any like in that space, right? You can actually get back that matrix anytime. Okay, maybe let us say
Actually, that final after getting the row reduced form or equivalent
Mm.
form, that the pivot element you can go back to the corresponding column for those the original matrix, and span of those will give you the basis.
Okay.
Okay, so you can think of like this. Let's say if whatever the independent vectors are there, right? So
Mm.
let's say you have any matrix. Do you know what is independent vectors?
Yes, sir.
What is that? How will you find out? Let's say you have matrix A here. Okay, maybe let's say 2 cross 2 matrix. Okay,
Mm.
1 2, let's say, and 2 4.
Okay.
Okay, in this case, how many independent vectors are here?
This
One, right?
yeah,
One.
one.
Mm.
One is the
Single
independent
prime
vector.
one. Mm.
So in this case, what will be the basis for A?
It is 1 2.
Yeah. So can I say that it is a span of 1 2 will be what? The column space of
Independent vector. Mm.
no, the column space of A in this case will be span of 1 2. What does it mean?
We can take any scalar multiple of this and
And
keep
you
yeah,
and you will get that vector A back, right?
correct,
So
correct.
in this case, if I wanted to represent vector matrix A, do I need this two vector to represent that? No, because if you think of this, right, these two vectors, this is also one of, let's say this is one vector, right, and this is another vector, right?
Mm.
Two vectors are basically onto the same line, right, in the space. Let us say, so here it's two-dimensional space, right? One dimension is another dimension, only two dimensions. So where is my vector 1 2? So one on this, let's say x and y, right? These are the two
Mm.
dimensions, and two
Axis.
will be here. So this is my vector 1 2, right? And what is my another vector? 2 4. 2 is here, let's say, and 4 will be somewhere here. So this is another vector, right? 2 4. Correct?
Mm.
Now the basis for this is this one, or you can say that okay, basis can be like this. If I just go again, and it will be, sorry, 1 by root 3 and 2 by root 3, right? It is a minimum vector which is needed for you
Oh.
to reconstruct that matrix A, right? So that matrix that
Mm.
will be somewhere here possibly, right? Now, uh, see, you see that what is the span of uh, or column space of A here? It represents a line. Why? You can, because so all these vectors, right, of this matrix A, they are actually onto the line. You don't need like any other dimensions here, right? Correct, to represent this vector A. I hope you are understanding this part.
Okay, sir.
And let's say you have another okay, and let's say you have another vector, another matrix, let's say 2 3. So now can I get only 1 by 1 2 to represent this?
No.
uh, no, right, because 1 2 will be this vector,
Mm. Or
and
2
2
3 is
3
different
will be
vector.
uh, somewhere. Okay, so this is the another vector, right? So if I
Yeah.
wanted to get this column space of A, it will not be just span of 1 2, it will be a span of 1 2 and
2 3. Mm.
right, and then whatever the linear combinations of this, right? What are the linear combinations of this? So everything, like let's say a plus, or a into, let's say, this matrix 1 2 plus b into this matrix 2 3, and
Mm.
a and b any real numbers, right? They can be negative, they can be positive, and if you think of that, right, they will span actually this plane, entire plane, right, within x and y, right?
Sir, in this case, what is the basis when we
So
are
in no,
taking?
this is not, the basis you'll have to find out is, now you'll have to go to find out this row echelon form, and whatever
Row
the
echelon form.
in that case, whatever the remaining vectors you will get right there, they will form you the basis of matrix A. So I can think of, you can think like simply, you can think of any two this kind of vectors, right? So one vector along this line, right, and one vector along this line, that will form a basis here.
Okay.
Okay, and basis of eigenvectors means what? So now your matrix A is there. Eigenvector also is a vector into like into the space, right? But let's say eigenspace, that will be a like inclined space. Let's say suppose so let's say you have your matrix A is in xy plane, and maybe the eigenvector space is like this. Okay,
Hmm.
let's say w1 and w2. Now this is another coordinate system. So previously you have this xy. Now what you are doing is all your data is actually shifted to these two, w1 and w2. Now you don't have to think about this x and y, because you are now getting these two vectors and like all these vectors. Right? In that, now you can treat it as a separate matrix of eigenvectors, and now you think of what are the basis for that. Understood?
Okay, sir.
So basically, if you have any matrix A, you will find out its eigenvectors, correct? And now
Hmm.
collect all of these eigenvectors into another matrix, right? All vectors, you just put it in column wise, you'll get another vector, and now you find out its basis. Got it?
Okay. Got it.
Yeah. So we can find a basis for eigenvectors in RD. Is it possible now? Yes, right? Or no? Okay. Regarding the statements, can you tell me like option A is not true, right? Because if A has to be a diagonalizable matrix, then it need not be symmetric. If it is symmetric, definitely it is diagonalizable. That I said. What about the second option? We can find a basis of eigenvectors for RD. Is it true or is it true or false?
We can, right?
Yes, we
Yeah.
can find. Because then what I said, no, like we can find out its eigenvectors. If A is diagonalizable, then what does it translate to? It translates to that it will have n independent eigenvectors, right? Now if you have n independent eigenvectors, then definitely I can make a matrix for that, those eigenvectors, which is, let's say, S, right? In that case, we said no, A is equal to lambda S or S lambda. That equation it has to follow. I hope you remember this one. uh, Here, this one, right? So this S is basically a matrix of n independent eigenvectors. So you can actually find out its basis. Can we find out the orthonormal basis of eigenvectors?
No.
That might not be.
Ah.
Let's say if your matrix A is symmetric, that case definitely your basis will be orthonormal basis, right? Yes, it is. It is actually okay. And what about option D? A can have some repeated eigenvalues, but must have distinctly independent eigenvectors. Is that true?
So this
Yes.
third one, why you are saying that we cannot find orthonormal basis of
Then,
eigenvector?
we actually find, but directly will not get it. You can find it using what? Gram-Schmidt theorem.
Gram-Schmidt.
Ah, correct, right? But see, it need not be like if you have any independent eigenvectors, it is not like it is not guaranteed that it will have orthonormal basis. Correct?
Sir,
Ah,
in case if the matrix is symmetric,
then it
then
yes,
then but we'll have to, then we can definitely find this thing
yes.
orthogonal basis. But the thing is that we might have to unitarize, like divide it by the norm, right? Basically, the eigenvectors.
Uh, yeah, but see, that's like divided by
Okay,
norm.
orthogonal. Okay, it's
Yeah,
not necessary. Got it. Got it.
yeah. So divided by norm means what you are doing is just like it's kind of saying like this, no? if I have vector A, and if I divide it by norm of A, what I'll get is I'll just reduce its length.
Yeah.
Like if I'm
Basically,
getting
getting the orthogonal matrix, basically.
right, orthogonal basis, right? So that is the only difference. Otherwise, it will not make. How this your orthonormal basis will be like what? Let's say this
90
is my
degrees.
eigenvector A1 and this is A2. They should
Dot
have
product is 0.
the 90. So A1 transpose A2 should be equal to 0. So basically, your eigenvector A1, A2 is another eigenvector. Let's say they are orthonormal basis when they will orthogonal, at least. Let's say
Yes.
they have to follow this thing, and
Right.
A2 equal to 1, right? But in general case, you might not get this equal to 1. That case, what you will have to do,
Understood, yes.
you will divide it
Then
by,
we'll have to divide the norm. Divide by norm.
you will get the
Yes, got it.
right. And when you have general matrix A, in that case, if you have any general matrix A, in that case you might get the what you might get this basis, right, which is not
Which may not be orthogonal.
right. Yeah, so the angle is maybe less than 90 or greater than 90, but it is not like that this case is also possible, right?
Yes, got it.
So if I talk about this question only, if any general matrix A is diagonalizable, I can definitely say about option B, right? Because if it is diagonalizable, that means it will have n independent eigenvectors, and if I have independent if my all eigenvectors are independent, right, in that case I will be sure that I'll get the basis for the eigenvectors, right, in RD. Correct, right? Let's say I shouldn't say n here, I should say what, D, right? Because it's a D cross D matrix. So in that case, you will have D independent eigenvectors. Correct, right? Huh? And you will get basis for eigenvectors. But can we get the orthonormal basis for general matrix A? Not.
Not directly.
Yeah. So it is like we cannot say it every
Yes.
time I'll get the orthonormal basis. That the matrix has to be special, and that special matrix can be a symmetric matrix or Hermitian matrix, right? Okay. And if you don't get the orthonormal basis, and if you wanted to get the orthonormal basis, the process is Grant-Schmidt process, right? I I hope you understand that part. Okay.
Yes, sir.
What else? What about option D? Is true.
Yes.
Option D is true, right? Because if you have some repeated eigenvalues, but it must have distinct independent eigenvectors, then only I can say it is diagonalizable, right? So when I say that matrix A is diagonalizable, even if it is having repeated eigenvalues, the eigenvectors corresponding to those repeated eigenvalues must be different, right?
Linearly independent.
Okay. Is that okay? See, if your concepts are clear, right, then I think tackling these problems will not be difficult. Okay, we can find a basis that is correct, and option B and D are correct, right? Okay. I hope any doubts are here throughout this discussion.
No, sir.
Okay. Which of the following statements are correct is the question number 13. If 0 is the eigenvalue of matrix A, then A can't be invertible. Okay.
True.
Let us talk about that. Maybe I'll just write down some statements here. Uh, what is singular matrix? Do you know what is singular matrix?
Determinant 0.
So let's say determinant of A equal to 0, or I can say determinant of A is 0, right? Okay. This is singular matrix, and singular matrix is not invertible, right? Uh, the matrix to be invertible, the determinant should not be equal to 0, right? So if any matrix is singular matrix, then that matrix is not invertible. What does that mean? In another way, I cannot be able to find out A inverse of that matrix. Okay. Another properties of the matrix are this, right? One is what? The product, sum of eigenvalues. Sum of eigenvalues should be equal to trace of the matrix,
Trace of.
right? And product of eigenvalues
Determinant.
values is equal to determinant of the matrix. I hope all of you know this. So what does that mean, right? Uh, Let us say your matrix A is like this: A11, A12, A21, A22. This is my matrix A. Now the next question is, what is the trace of A? It is A11 plus A22, right? Sum of the diagonal elements, right? Okay. And what is the determinant of matrix? Uh, Determinant of A is A11 into A22 minus A12 into A21. Is that fine?
Fine.
Let us say this is a 2 cross 2 matrix. So how many eigenvalues it will have? 2 eigenvalues it will have, right? So lambda 1 and lambda 2 are the 2 eigenvalues of this matrix A. Then in that case, what will be the trace of matrix? A11 plus A22 is lambda 1 plus lambda 2, and this is equal to lambda 1 into lambda 2, right? As we have seen above. So if one of the eigenvalues of this matrix lambda 1 is equal to 0, in that case, what will happen to determinant of A? So 0 into lambda 2 will be what? 0, correct? So that means what? Determinant of A is equal to 0. And if the determinant is 0, then what kind of matrix is this?
Non-invertible.
Singular.
Singular.
Non-singular or singular matrix, right? So if it will be a singular matrix, and then it will be a non-invertible matrix. So can you tell me now, what about option A here? If 0 is the eigenvalue of matrix A, then A can be invertible. Is that correct?
Correct.
Yes.
Okay, what about option B? If all the eigenvalues of matrix A are 0, then A is a 0 matrix. Is that true?
Need not be.
It not be, right?
Did not be.
Because in that case, if we cannot say, right, like if it can be different matrix with all, you know, one of the special case will be what? Maybe you can think of a upper triangular matrix with diagonal elements as 0, right?
Yes.
I'll show you what is that mean. So okay, I will tell you. Matrix A is like this. Let's say 0, 1, 2, 0, 0, 1, 0, 0, 3. What are the eigenvalues? Oh, sorry, 0, 0, 0. So what are the eigenvalues of A? They are equal to, actually in this case they are the diagonal elements, so all zeros, right? So this is one of the eigenvalues, this is another eigenvalue, and this is another eigenvalue. So this matrix will have 0 eigenvalues. But does this is this a 0 matrix? What is 0 matrix? 0 matrix is this matrix: 0, 0, 0, 0, 0, 0, 0, 0, 0. So all the elements of that matrix has 0. But does this qualify for this? even though eigenvalues are 0? No, right?
No.
So option B is correct or wrong? Wrong. Okay, what about option C? If 3 is the eigenvalue of matrix A, then 9 is the eigenvalue of A square.
That is correct.
Correct, right? This is the
True.
property of the eigenvalues, right? Okay. What about option D? Every 2 by 2 matrix has at least one real eigenvector. Is this true or false? We can't say, right?
It's not specified if it's complex or if it's real.
Yeah. So it can be a complex eigenvector.
It
It can
can
be a,
be yes. It
yeah.
cannot yes, correct.
Right. So it doesn't say, like, it is not possible, I guess, to say about it, right? So only two correct options are: if 0 is the eigenvalue of matrix A, then A can't be invertible. If 3 is the eigenvalue of A, then 9 is the eigenvalue of A square, right? Okay. Uh,
So this last one, it is saying at least one real
eigen.
eigenvector.
Ah,
So we will always get an eigenvector, but whether that will be real or complex, that is not known.
yes, and at least one means, like, so if it is 2 by 2 matrix, how many eigenvectors will get? Two.
Okay.
Two, right?
Yeah, yeah.
Maximum two we can get, and that means it will have two eigenvalues. But is it, like, always the case that you will be one of the eigenvectors is real? We can't say, right? Both
Hmm.
of the eigenvectors can be complex or imaginary,
Okay.
right? So that is what it is saying. There is no uh, like backing to that statement. That's why it is incorrect. Okay, what about question number 14? The length of the error vector obtained by projecting u onto v is. Do I need to solve this, or can I skip this?
I think you can skip this that we discussed, right? This
Yeah,
in this case
yeah.
it is a vector, so we can
What
directly divide and
what it will be? What will be the error vector? Okay, I'll just write down the equations. Then maybe we can skip. Uh, so basically, you wanted to project u onto v or v onto u. Projecting u onto v. Yeah. So your this will be your v is going to be your u. You wanted to project u onto v. So that projection here will be what? U transpose v divided by,
so this will be you transpose u. Yeah.
right, and that is this is a scalar, and I'll have to multiply that with v, right? And basically you will multiply with this. So your projection vector, so that is going to be your projection vector. This is going to be p. So p is basically v times u transpose v upon u transpose u, or you can say that it is v uh, v. Is it
So
wrong?
we will
Is
come
it
one
u?
time
I
only,
think
na?
it's multiplied by u or v.
Multiplied by v, because this is the case.
So
Uh,
in the denominator, we should.
I think, what is it? V transpose v, yeah. Okay, just a minute. I'll.
So is
So
just
it's a u into u transport divided by u transpose into u into v.
so
Into
just
V.
not to miss it, if we just parallelly draw a B and A, and then compare it, what is the U and V
Yeah,
with
yeah.
B and A.
This should be v transpose v. Okay. Let us say this is your a, and this is your b, right? In that case, it will be a transpose b,
By A transpose
okay, multiplied with
Dot
A,
A.
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 So in this case, you will be this one, right? U
So
transpose
we
V or V transpose V. See, that is the same actually. Okay. I think the confusion is because of U transpose V I written, right? Basically, U transpose V and V transpose U are same, right? Why they are same? It's a dot product. So here I can say that it is V transpose U. So your familiar statement will be like this: no? V transpose upon V transpose V times U.
Yeah, actually the V is A and U is B.
Yes. And you will have to solve for this and then find out its length. You get a vector. This also I think we have discussed it. Consider a line with zero slope and
Sir, my 13 and 14 questions are at different.
what is it? Your different questions, sir.
Yes, sir, in mock quiz one. May I share the screen?
No, what is the like? But that is fine, right? I think it's okay, right?
But sir, my options are maybe wrong. I think so.
Okay, okay. You can share that. I will see.
Sir, I think symmetric matrix will not be a correct option, right?
Symmetric matrix is the wrong option, sir.
Which
It's
of
the
the
wrong
following
option.
options is or are
It is
true?
conjugate transpose, right?
I think this question is there. It's coming anyway. I'll discuss it. Okay, don't worry about it. I'll discuss it.
Okay, sir.
Okay. Oh, okay, okay. I don't have that question here. Fine. I think that week 5 questions are there, right?
Yes, sir.
Okay. I think okay. So the mock actually which I have opened here is the previous times mock, right? And that time only week 1 to 4 was the syllabus. But okay, no issues. We can solve for that as well. No worries about it.
So week 5 also some question will be there, sir. Like
Yes. So I'll discuss some of the questions from week 5 as well. This is okay, right? Do I need to solve this? This is fine. We have seen already, right? It's kind of similar of as this question, which this one, A and B, correct, right? Here, can you tell me what should be the matrix A look like? Okay, I'll just write it down for you, and then we can move to the week 5 questions. Can you tell one of you? Okay, you don't have that question in your mock. Yes, I'll write it down. 1, 2, 3, 4, and 2, 4, 1, 3. A, X and Y. Here is 1, 2, 3, 4.
We cannot see your screen, sir.
Oh, is it?
Only question number 15.
Oh, I think I shared window. I didn't share.
so solving question, are you using mouse and notepad or you are using some device, sir?
No, I'm
Just
using the device. The only problem here is I have changed to the different Windows, right? So now I'm using Windows. Previously, I used to use that Ubuntu system, the operating system. So it is like not much compatible here with Windows. This device. I'll from the next session onwards, I will use some other tool possibly.
okay.
Okay, so but still it is fine, right? It's like not bad, right? That bad.
Yeah, good only. I mean, you can understand that.
3, 4. This X, right? And your Y is I think 2, 4, 1, 3. 2, 4, 1, 3. Right? So what will be matrix A in this case? Can you tell me? I think one of the sessions I have discussed about that. You can actually formulate a C plus dt system equal to B, right? Or Y, let's say. Maybe if I wanted to say in these terms.
It is we are very familiar with y is equal to mx plus c.
Yeah. So in that term, let's say C plus mx equal to y. Is that fine?
Yes, sir.
And now if I wanted to write it down, how it will look like? C and M are the unknowns to me. Then in this case, this all equations will be looking like this: C plus M1 equal to
2.
C plus M2 will be looking like, or okay, rather I'll write like this: 1M, right?
M 2M.
M 2M equal to 4, C plus 3M equal to 1, and C plus 4M equals to 3. Do you think that this system of linear equations is consistent?
No, sir. That
All right.
3 x is equal to 3, then immediately y
Yeah.
changing.
So what does that mean is we do not have the solution to this problem, right? So in that case, what you do? You try to find out the approximate solution, and
Projection.
right, and you do projections. In that case, my what will be my matrix A will look like if I wanted to represent this system of linear equations into this case. X equal to B, and X in this case will be, which are these two?
1
C
2
and
4
M, right?
1 1.
Correct. C and M are these are the variables, right? What will be my matrix A in that case? It will be 1 1 1 2 1 3 1 4, and X will be C and M, and equal to B is 2 4 1 3, right? Is that okay?
Yes, sir.
Now I need to solve this, and I know that there is no solution to this problem. I'll do using the projection of the. And what will be the solution in that case? A transpose x hat equal to A transpose B, right? This is my A, this is my X, this is my B. Okay. Now what we should do here is, oh, I think A, not A transpose, should be A transpose A. Both sides I said no, both sides will have to multiply by A transpose. So in that case, it will be A transpose A. Okay. Now what I'll do for it, I'll solve this A transpose A augmented A transpose B, right? And I'll just solve for this. 1 1 1 1 1 2 3 4. Then the matrix will be 1 1 1 1 1 2 3 4, augmented with 2 4 1 3. And now I'll find out C hat and M hat. Is that okay? And this, and okay, and then you'll have to find out the residuals. Residuals will be able to find it out. What is residual?
The error.
Errors, right? And how will you find it out errors? So here you'll get C hat and M hat. What else you,
Yes.
then what you do later?
We just need to find A into X basically with the
So
revised C and L here.
yeah, so you can do one thing. You whatever C hat and M hat you have found out, right? Put them in, plug them into these equations, right? You'll get that y hat, let's say, and this is your y, right? Actual y, and you actually get that y hat minus y, and you'll get the errors. Do I need to solve this, or if, see, if you're not comfortable, I'll solve this. Otherwise, let me know. Okay. So the final equation. So okay, let us say this C hat and M hat will be there. That is what your X hat, right? Then your projection vector will be what? AX hat, correct? Hmm? And there is one B equals to P plus C, right? This you know. Do I need to solve this? You tell me. Otherwise, see, I'll solve it like maybe in 10 minutes. But
You
yeah,
can solve it, sir.
You'll solve it, right? So every time your reference should be which diagram? These two diagrams. I'll tell you the reference. This is A, this B for vectors, right? This is vector B, and error vector is this, right? And this is what? Position vector. So error vector will be B minus P, correct, right? In that case, your B equal to E plus P, and P will be equal to AX hat. X hat is equals to the C hat and M hat. So this C hat and M hat, once you find it out from here, you'll get, you know A, you can get P, the P vector. And what is your B vector? B vector basically is this one, right? 2, 4, 1, 3. Then this P vector, sorry, B vector minus the P vector, you'll get the E vector. And this E vector is the residual vector. And if you wanted to find out the length of the vector, you can find it out the length of the vector. Is that okay? Okay. I okay. I think, see if your geometry, see if you understand the geometry of it, right? I think it is like super easy, but I don't know. It will take little bit of time to understand, get it into. But if you don't understand it, you just draw it in the exam paper. Also, you draw it, draw those vectors, and then you will get it.
Excuse me, sir.
Yes.
Sir, then what is the use of the statement that y is equal to 2? Intercept from y.
Where is y equals to it?
Previous question that you were explaining. 16. Yeah. Y intercept of 2.
Okay.
Consider line. Yeah.
So, okay. I think this question you don't need to find out that. I guess you already get that slope as 0 and y-intercept of 2, right? So that means
Yes.
m you know, and this also you know. So I think it is again very easy, right? Okay, in this question I don't need, you will need to solve by all this calculation. I missed that part. So you already have given the solution. So what is the solution? X hat is given to me as uh, 2 as intercept and 0 slope, right? Correct, right?
Yes, sir.
Now you just have to plug in all of these values. Mx plus c. Uh, so m is 0 basically. So every vector of y hat will be what then? 2, 2, 2, 2, right? And your y vector, which is a b vector, what is it? 2, 4, 1, 3. Is that correct? What are you able to understand or connect it to me?
हाँ ले आया था ना घर पे पढ़े
That is correct, sir. That is why.
Correct. No, because now this 1, 2, 3, 4 doesn't hold value because your slope is 0. So this was y and this was y hat. What will be the residual now? Like this minus this, right? Y minus y hat. 0, 2, minus 1 and 1. And what will be the length of this vector? 0 plus 4. So square root of
We did y minus y hat. That is the error. Okay.
correct, na? Actual
correct.
value minus the predicted value. So it is like 0 plus 4 plus 1 plus 1. So it is root of 6. I think that should be your answer to this question. Root of 6 will be okay. And squared, sum of squared it is asked. So if it is squared, then root 6 square. 6, right?
Yes, sir.
Okay,
Yeah,
sir.
this was like, okay, I think that was like simple question. I missed that part. Like it is given to me. So if this is not given to you, then how will you find it out? That I told you, right? Okay. See, we have like limited time
Sir,
today, so I'm not like delving into so much. Otherwise, I
sir,
can.
is there any correction in last question of quiz?
Your voice was not clear. Can you just repeat it again?
Is there any correction in last question in mock result?
No, no correction. I think that is the mock you are saying, or the which was I'm
Mock last question.
this one.
Is it? Isn't it true?
If the matrix A is reduced to a triangular echelon form, the number of free variables is. You'll have to solve this. I've solved it. I didn't solve it right now, so
So after solving
Can you
this,
solve?
whenever we get non-pivot element, those are free element.
so how many pivots you have got? Three, right, or two? Two pivots, right? Then you will have
Two
three
pivots.
variables. Yeah, then you will have
Yeah.
three free variables, right? See, the free variables are those variables which are not pivot variables. So if you get two pivots, then that means these two columns will be your pivot columns, and the remaining columns will be the columns of free variables, right? How many variables does this matrix A have?
Got.
Five, right? This matrix A have five variables because the number of variables are equal to number of columns. And once you get two pivot variables, then definitely it will have three free variables remaining. Correct, right? And I
Sir,
think the rank of that matrix also be equal to 2, if I'm not wrong. Yes.
what I was going to ask is that if we practice all the pattern given in the mock,
Yes, yes. You can be able to. Yeah. If you understand, right? If you understand, similar kind of questions will be asked. Nothing is like different than what we have discussed. Okay. Maybe I'll
yeah, okay.
take these 2 3 questions from here. Like what is Hermitian matrix and then we can stop. Okay, maybe I'll take okay, positive definiteness I'll talk about, and the matrix Hermitian and unitary. Fine. Then we'll stop.
So positive definiteness, is it in? It's not in week 1 to week 5.
Oh, it's not there. Huh? Okay, then I
No,
think
not at all.
then okay, then we need not. Okay, I think it will come in week 6. Oh, sorry. Okay, fine.
Sir, one doubt on uh, quiz one, question 14.
Mock quiz 1, question 14 means
Quiz,
what?
So that question that I shared.
Okay. Okay, give me that question. Okay. Can you just share that? I'll stop presenting my screen. You share that screen. I'll write it down. So okay, now I think then we are remaining with that Hermitian concept, and if you want more, right? I think I have taken one session in like solve this session. You can go through it. All the questions are like similar to that.
yes, sir. In this question, how is A a symmetric matrix?
Okay, I'll tell you. I'll tell you how that is. But uh, okay, does it have any related question, or is it like this is a
Yes,
related?
sir. There are two
Okay.
questions, 13, 14. Yes.
Okay, this one, right? Okay. Oh, now you can stop the screen and let me tell me the question. Okay. Yeah. What is the question? What is a matrix A? Row wise, tell me. Yeah. Row wise values.
2 minus I.
Two.
So you are not sharing your screen?
Oh, not a. Sorry. See, I think all of you know the concepts. The only thing is how to apply it. You'll have to, and during quiz, like sometimes it is possible that you might forget that, right? So how to tackle all the issues is you go from the basics. Don't panic, just go from the basics. What are the basic definitions of everything? Yeah, two.
Minus I.
Hmm, and
I2 minus I.
I two minus I. Yeah.
Minus I2.
Okay. Yeah, this is not going to be, and the option C was what? A is a symmetric matrix, huh?
Yes, sir.
Yeah, A shouldn't be a symmetric matrix. Yeah, I think that is wrong there. Because if I look at this, right, this is not.
Yes, sir. Someone answered in the discourse that it was wrong option and option A was correct.
Yeah, yeah. So that shouldn't be the case. We'll think about what the Hermitian matrix. So when it is Hermitian matrix, when A equals to A star, right? then in that case I'll say that the matrix is the Hermitian matrix. And what is A star? A star is a conjugate transpose of the matrix. It can be written as first of all you'll find out its conjugate and then take transpose or A transpose conjugate, right? I will go by this way. What is A conjugate first of all? What should I do in the conjugate matrix? Whatever the imaginary values are there or the complex numbers are there, I will change the signs
Sign.
of those. So in this case, it will be 2 minus I will become I will become minus I. Here it will become minus I 2 and I. Then here it is I minus I and 2, right? And then A conjugate transpose, which is again A star, is equal to what? I'll have to take the transpose of this matrix. So the rows will become columns and columns will become rows. So the first column will become row. It will be 2 minus I. Then what is it? I 2 minus I and minus I and 2, right? Okay. So is this matrix A and this matrix A star, are they equal?
Yes, sir.
Yes. So that means this matrix A is Hermitian matrix. What are the options? So first option was what?
Sir, about that A equal to A star.
So is it correct?
Yes,
Yes.
sir.
Okay. What is the second option? Can you read that? Read those options.
Yes, sir. First option was about A star equal to A. Second is of A is a symmetric matrix. Third is A is a Hermitian matrix. And fourth one is columns of A are orthogonal.
Okay. So first option A is equals to A star is true, and if the first option is true, then the third option is also true, right?
Yes, sir.
Then we called it as a Hermitian matrix. A is not a symmetric matrix, right? And what is the third last option?
A is orthogonal.
A is orthogonal matrix.
Columns of A is orthogonal.
Okay, columns of A are orthogonal. Okay, so let us say what are the columns of A. So basically the columns of A are that of columns of A star, right? How to check the columns of A are orthogonal? What is the condition on orthogonality between two vectors? Let's say if you have A and B as a vectors, then A transpose B should be equal to 0, or dot product between these two vectors should be equal to 0, right? So this C1, C2 and C3, these are the three vectors. I'll have to check 2I minus I and 2I minus I, right? What is the, it will be a scalar, so it is 4 plus I square plus I square, right? It is 4, I square is minus 1 and minus 1, which is equal to 2. So does this column orthogonal?
No, sir.
No. So do I need to check for others?
No, sir.
But basically what you will have to check is C1 transpose C2 equal to 0, C1 transpose C3 equal to 0, and C2 transpose C3 equal to 0. If these three conditions satisfies, then we can say that columns of matrix A are orthogonal. Is it possible that C1, I checked C2 transpose C1 equal to 0?
Sir, in this one, I'm sorry to interrupt.
Yeah,
Sir,
yeah.
in this one, like you are multiplying 2I minus I with 2I minus I, right? This, like the
No, no, I have multiplied this. I'll multiply it with this, right? This 2 with this 2, this I with this I, and
but
minus.
sir, in this, since it's a complex, it will become a conjugate, right? In one.
Yes, yes. Oh, okay, okay, sorry.
2 minus I plus I into 2I minus I,
Here
right?
it is minus I and here it will be plus I. But okay,
Yes.
I don't think still the answer will change.
It won't. Yes, yes, yes. You
Yeah,
are
but
right.
yeah, that is true. Whatever you said is correct. Because it's a complex, Basically
Yes.
you'll have to do C1 conjugate
Conjugate
and
into
C2,
transpose, yes.
C2 conjugate transpose and, right.
Yes, yes.
Okay, I just forgot that part. Yeah, this is possible. Okay, all of you just remember that. Uh, when you deal with complex, I think in the previous session also I have mentioned that, right? It is possible.
Yes, yes, yes.
It's
It's,
good that you.
sometimes it creates a mistake also.
Yeah. So basically, this will become plus one,
4 plus
and
plus
then this will become 6.
6.
The answer to that question remains same, but yeah, the value has to be 6, not the 2. Okay, this is okay. Right. So let us see any other question. If you have, you
Sir,
can.
can you please find the eigenvalue of that matrix?
Which one? This
Sir,
matrix?
that last this.
Okay, I'll find it out. Let me know that A matrix A. What is, again? You tell me the matrix A so that
Yes, sir. 2 minus I.
row wise, right?
Yes, sir.
2 minus I.
I 2 minus I. Minus 2
So
and
I 2 minus
I
I.
is not in with minus 2.
I.
2 minus I.
2 minus I.
Okay.
Minus I2.
This is my matrix A, right? What
Not
about
minus 2, sir. Only 2 is there.
okay? So basically, you wanted to find out the eigenvalues of this matrix A,
Yes, sir. Yes.
and they will. That means you'll have to find out the determinant of A minus I lambda equal to 0, right? This equation you'll have to solve out, right? Basically, that will become your 2 minus lambda minus I 2 minus lambda minus and minus I and 2 minus lambda, and say this is the right.
Sir, can I say something in
Yes,
this
yes,
one?
yeah, yeah.
Sir, because since sir, if you look at the option, na, sir,
Hmm.
because I think if we go this way, it might take some time.
Hmm.
So what we can do is that, sir, we can find the determinant of A.
Hmm.
And as we know that, from the options, as we can see, we can simply see, sir, which multiplication of which eigenvectors are giving me the determinant. So from that also, I think we can do.
Okay, I don't know what question is there. That's why I'm trying to solve.
Okay, yeah, correct, correct. Got it.
Yeah, so but it's okay.
Option is of sir, diagonal of that eigenvalues.
It's okay. Why I'm solving this is like to maybe
Understood.
the question will be there in case, right, to find out the eigenvectors of or eigenvalues of complex matrix. So just to practice, you can look at it, right?
Understood. Sure.
So what we so it's like basically the same what we are doing for real matrices, but okay, the calculations become little bit tough in this case, right? Can you tell me what is it? 2 minus lambda into 2 minus lambda times 2 minus lambda. What is this? Plus I square, right? Uh, then this will become plus I into I times 2 minus lambda minus I square and plus I times um, I square plus I times 2 minus lambda, right? Okay. So, and that has to equate it to 0. So, what should I do now? Here is 2 minus lambda here. This is what? 4 minus 4 lambda plus lambda square minus 1 plus I times 2I minus lambda I plus 1, right? Plus okay, plus I times minus 1 plus 2i minus I lambda, right? Is that okay?
Yes, sir.
So now you can actually okay, then expand it right now. Okay, fine. So it is again, I'll do one more step: 2 minus lambda into lambda square minus 4 lambda plus 3 plus I'll open this bracket, so 2i square will be 2i square will be minus 2, then plus lambda, right? Because that will be minus lambda I square, so that is plus lambda plus I minus I minus 2, and then I square is minus 1, so plus lambda, right, to 0, correct?
Yes, sir.
Okay, so my I don't know how to add the page here. Can anybody remember this part and tell me? Maybe you can take a screenshot and let me know. Can you take this part here? No. And I solve one more.
Yes, sir.
You are done. Taken it?
Yes, sir.
Okay. Yeah. So I think I should add here, right? Yes. Here, what was it? 2 minus lambda into lambda square minus 4 lambda
Lambda plus 3
3.
minus 2.
So basically, I can actually cancel out this. So this will become minus 4 plus 2 lambda, right?
Yeah.
Now open it again. 2 lambda square minus 8 lambda plus
Plus
6 minus lambda cube plus 4 lambda square.
Sir, we can do one thing here.
You can take 2 minus lambda
2
common.
minus lambda common here.
Minus lambda common, yes, right.
Possible. It's not possible, right?
No, no, we can do minus 2 into 2 minus lambda, na?
Yeah, that also you can do. Yeah, and then you
That
can
we can
solve
do.
only for this, right? Yeah, that's fine. That also you can do. Or okay, now I have written it, so I'll
Okay.
just finish it off. So what it should be? It will be minus lambda cube plus 6 lambda square. Then this 8, 11 minus 2, so minus 9 lambda, right? And plus 2, so it is 0. Okay. 0. So now we'll have to check which equation will satisfy, which value will satisfy this equation. So suppose if I put 1, in that case 1 minus 6 will be minus 1 and so 9 and 8, 10. 1 will not satisfy that. Minus 1, minus 1 will satisfy this. Minus 1, minus 6, minus 9, minus 2. No, right? How to solve?
So two will satisfy.
2, huh? So 2
Yeah.
cube is 8 minus 4 into 6 is 24 plus 18 minus 2. 2. So 18 plus 8, 26 and 26 and 26, right? So 2 will satisfy this. So one of the eigenvalues will be So lambda equals to 2. Now we'll have to find out other values. I don't know whether you know this. It is minus 6, 9, and it's 2. And if you have 2 here, then it will be, I think, 1.
X square minus 4x plus 1.
This is basically a quadratic equation. So one of the values is lambda minus 2, and there is lambda square minus 4 lambda plus 1 equal to
Yeah.
0. So one of the is here it is definitely lambda equals to 2. What about this? I think a equal to 1, b equal to minus 4, and c equal to 1. In that case, what are the minus b plus minus root of b square minus 4ac upon 2a, right? That will give me the values here. So minus b will be plus 4 plus minus root of b square is 16 minus 4ac is 4 divided by 2a is 2. That will be 4 plus minus root of 12 by 2. Root 12 I can write as 4 into 3, which is 4
3
plus
root.
minus 2 root 3 by 2. So the final thing is 2 plus minus root 3. So what are the eigenvalues here? So lambda is equals to 2, 2 plus root 3, and 2 minus root 3. I hope all of this is correct. If I'm
Yes, sir.
not
Yes,
wrong,
sir.
then
Thank you, sir.
it should be
That's correct.
okay, right?
Excuse me, sir.
That and mostly
Hello,
the questions
excuse me,
will
sir.
be on this. Correct. Yeah, yeah. Now you can tell me. You have any questions? You can tell me. We'll finish this session in 10 minutes, 10 or 15 minutes. Yeah.
So I have a query, sir.
Yes.
So the equation no, for this the eigenvalues equation, it
Ah.
becomes complicated when we have a combination of real plus complex values.
Okay. Yeah.
So how to simplify that in a shorter time? Could you please help us out with that?
Uh, there is no like shortcut to that, right? At least I don't know. But see, I in general, right? Like in the quizzes, we don't ask that kind of questions. So if you think right, mostly the questions will be like very similar to you can say quiz one, or maybe sometimes will not ask. So the questions will be like this. I'll tell you. One of,
Sir,
yeah,
in
like
mock
this.
one, there is a question regarding
Yeah,
this.
which one? Can you tell me the question?
Just
But nowadays we don't ask actually so much of questions which are based on the calculations. But yeah, you can tell me what is the question and then
Sir, for example, some questions with the 3 cross 3 matrix, and then we need to calculate inverse of that, like P inverse of DP, and then inverse calculation will be little time
that you'll have to
consuming
do.
that time.
No, I think that you'll have to do, right?
Yeah, that's okay. I will do that. But I'm just telling that
Yeah,
the
yeah.
cofactor and then and
Yeah.
you were saying something. You were
Yeah,
saying
yeah.
something.
So generally in the questions, right, in the question paper, we ask the questions if I wanted to find out the inverse, right? Mostly it will be 2 cross 2 matrix or 3 cross 3 also. It will be like calculations will be easier. Not much hard calculations will be asked. So see, basically the questions will be this type. So if some matrix is given and there will be 4 5 options, and we'll have to find it out like whether that is correct or not, right? That kind of questions you can see in the tomorrow's question paper also is kind of like that. Questions will be like that.
so I found the question. It's in GA5 question 6.
Yeah. GA.
GA5 question number 6.
Hmm. This is like kind of hard, right? So that kind of calculations will not be there in quiz.
Sir,
but it is solvable. See, I can solve this question also, but yeah, I understand it. It will take like a lot of time to solve it. This is for your anyway practice purposes, so that's why it is there in grid assignments, because you have much time to solve this, right? At home you can solve it, but in quizzes I understand that you see it will take like at least 15 to 20 minutes. If you are good at calculations, it will take at least 15 minutes, I think 15 to 20 minutes.
Sir,
Sir,
I don't think.
Yeah, one by one.
sir, sir,
Uh,
one approach I had in mind is I tried to, dot product of the matrix even in the options. So
That
because eigenvectors are orthogonal, so
okay, that is also. But eigenvectors are not always orthogonal, right?
orthogonal, sir.
Why?
For Hermitian
For
matrix, it is.
Hermitian matrix they are.
Hermitian matrix, right? So
For
is this
Hermitian
Hermitian
matrix they are.
matrix? If it is there,
Yes, sir.
yeah, then that approach is correct.
But sir, in general, K-sub is not a Hermitian matrix, and it's a combination of real plus complex numbers. So is there any shortcut or any some simpler way to solve this
No,
to find the eigenvectors?
no.
Yes, sir. So we
Yeah,
have to go the long way.
yes.
Okay.
There
Thank
is
you.
no way actually. So it's like the same process we'll have to follow. Right? Yeah.
Then you have to post multiply with those eigenvectors and check if you are getting some scalar of that.
Yeah. Again, it will take that much of time, right?
I think that's better approach than finding the determinant of A minus lambda. That will
For
take.
that we'll have to, yes,
Hmm?
exactly. That's a good approach. For that, though, we'll have to like scan all the 12 of these, or
Yeah.
Yeah,
10,
yeah.
at least 10 of those.
So
We'll have
let's
to
just
scan.
say if you
There
ask me
is
to
some
solve, right?
similar.
Yeah, if you ask me to solve this, right, I may not go option wise, because see it will take time. Even if I do some slightest mistake, right, I'll end up being the choosing wrong options. So what I'll do is I'll just solve it like traditionally, like take a matrix and like solve it. I think that, but still, yeah, both of the approaches will have their own issues. But see, only this course, right? This MLF course, you need to find out this matrix calculations. Like it will be there. After that, it will not be there much. In like MLT, you will have like very minimal calculations. After that, you anyway you will be solving all of these matrices using the programs, right? So this is not be there later on. But it is good to understand it manually, right? So if you know the process, whenever you write a program, that time also that will be there in your mind, like how these calculations are happening in that program, right? So that way it is good. That is why this course is actually required. Otherwise, if you ask me, if you are going to become a data scientist or some other thing, like in any company or somewhere, right, or in general also, in that case you don't need to do all these calculations manually, because the data in real life will not be like 3 cross 3 matrix or 4 cross 4 also, right? It will be like 1000 cross 1000, or like it's like very
Right.
big data, and mostly you'll have to take a help of uh, coding, right?
Right.
So all packages are there, and but how they are working, right, in the backend, if you know that, then understanding the algorithms, machine learning algorithms, it will be like very easy for you. So that is a okay.
Sir, I
I
have one
Yeah.
question.
Yes.
Uh, because I missed the few minutes before because of the electricity cut at my
Okay.
region.
Yeah.
So my question was when there is a questions related to find the best match, best line fit for the given data set, like X and Y given and all.
Huh.
So whenever I'm solving this one, my equations are like always be different than the options, then I am just trying to match which is near to that my equation. So is it something purposefully, or is my I'm doing some mistake in that?
I
I
don't know.
don't know, sir.
There are two ways. If you're not getting the right answer, is like if the data whatever is given to you, and the answers to that, right? They are in, let's say, decimals or something. So some it is possible while calculations you do you take only two digits, let's say, right, after the
Mm-hmm.
decimal points, and somebody has taken the four decimals is like the, the safest one basically. It will round off like the error will not be too much when you take the 4 decimals. Uh, that is the
But
issue.
sir,
Or
but
else,
my problem was something when you are calculating like y equal to mx plus c when so my approach was something to get y hat like mean of y and mean of x, and then depends upon that I'm calculating m and c in the equation.
no, the data fit line here you are using, right? That is not the right approach here. That you are doing by using the linear regression method, y hat
Yes.
minus y. No. Here you will have to use the linear algebra method, the list
Okay,
square
means
method.
means the same way like
It is
calculating.
so that I think
Uh,
one of the questions I did today, you'll have to do that. Like A transpose A x hat equal to A transpose B, right? You'll have
yes,
to
yes.
solve that equation. Then only
Actually, while going through that only the power cut happened and I missed that part.
okay, you can anyway. This is like this one, right? YouTube stream. You can go back,
Okay,
and I think I have
okay,
attached that link to this calendar also. You can start that session from there. You will have to like whatever 15 to 20 minutes you missed, right? You can actually watch it there again. And I
okay,
think one of the
okay,
sessions, previous sessions also have explained it like properly, but you don't need to go and watch the previous session. Today's session you can actually go back and watch the first, I think, 20 or 30 minutes. You'll
okay,
get,
sir.
and that is the only approach, right? Because the approach you are solving is the linear regression approach, and that's why you are getting different answers.
Yeah, sir. Now maybe
Yeah,
it's clear because yeah.
yeah.
So
So
and I can get that videos from our calendar link only, na, sir.
yeah, it is there. You can actually get it from YouTube also if you're subscribed to the MLF channel, but don't worry about it. It is there. If you now also you can check it. It is already present there. That link.
Okay, sir. If you don't mind, can you just paste that into the message so I can just
Yeah, sure.
uh, I can just immediately
Yeah.
click on subscribe and check it.
Yeah. You wanted that, right? So I'm
Yeah,
testing the
yeah.
link. You can take it. Yeah. I think somebody has already posted.
Yes, yes.
Sir,
I got it, sir.
Yeah.
Thank you,
um,
sir.
Yes, Devang.
yes, sir. I have a doubt in linear approximation questions. One I have posted in the chat box also.
Hmm.
So can you please tell how to approach that question?
Okay, let me see. Consider a function. Yeah. Okay. Let me solve that. This is the question, right? Consider a function,
Yes, sir.
and I think you are missing with that this part, I guess. Uh, okay, I understand. I think you are doing it right. The only thing is, what are you taking for pi here, or how you are actually calculating sine of this? Are you working in radian mode or are you working in the degree mode?
Sorry, degree mode.
And that is why I think it is getting wrong. But okay, don't worry about it. Let me solve it. So, what is the formula for this linear approximation? Okay, so let us say in two dimension, I think it is L of xy. Basically, it is a vector, right? It should be equal to I think f of xy plus uh,
F
Gradient.
dash X Y, sir.
I think
It
x minus x naught and y minus y naught times the gradient of, right? I think that transpose
yes.
gradient.
This should
So
be
Gradient is
L of
gradient.
f of x naught y naught plus
yeah. Okay. No, not f of,
Gradient is
right. I think
no f of x naught y naught plus x minus x naught y minus y naught delta f of like gradient of x naught y naught. Then you need to put that x naught.
yeah, this is okay.
Gradient part is
It's not a,
before the
what about this? This is correct, right? Okay, normal. Okay,
yes, sir.
normally what you do? Linear approximation of x is f of x plus x minus that around that point, right? Times f dash of x, right?
F of x zero.
Okay, f of x zero here also.
Yeah,
Correct, right?
yeah,
Here I think say in two dimensional case it is x naught y naught and x minus
Yes,
x
sir.
naught y minus naught if it is vector format. Okay, right. What is your function in this case?
Sine of x, I think.
Sine of xy. And what else is
That's
there?
it, sir. Only sign.
No, the point is this one, right? Around the point pi by 2 0, right? That point I wanted. So the point is, so x naught y naught, right?
Yes.
Correct, right? This point.
Yes.
So I need to find out its gradient. So gradient of f. So I'll be working into now vector space. So what is del f with respect to x? It is cos of xy into y, right?
Y into, yeah, y into cos of it.
So, this,
And the other one is
and it will be
X
x
cos of
into
xy.
right. Okay, and at what point? Pi by 2 0.
0.
So cos of 0 basically, right? It will be 1 both the way, and it will be like y is what? 0,
Yeah.
correct?
3. Yeah.
Pi by 2, right? Or 3.14 by 2. That is
Yeah,
also
1 point.
if you wanted to use that.
The
I'll keep
question
that,
they mentioned.
yeah, I'll keep pi by 2 here as it is. So now the linear approximation I need to find it out. So that will be your function at xy, right? So x naught or y naught, what is that? Sine of 0 is
0, sir.
0, and sine of like function at uh, is that correct? I think it is 0
So
0,
it
right?
will be
Yeah,
linear.
that's correct.
Plus uh, I think x minus x naught is 0. No, sorry, x minus.
Sir, below one will be pi by 2, right? 0 and pi by 2, I think. X cos xy.
I think it is function of x naught y naught, right?
Yeah,
Sir, it should
that is
be
0 only.
sir, it should be transpose of this, na? Because it's going to a linear equation. From what we are doing, it will give
Yeah,
us a vector matrix, a vector.
you can actually do both the transpose. That's fine, right? No.
Sir, sir, I am saying about this x cos xy, right? It will be pi by 2,
The
no, sir?
the first term is anyway 0, but it should not be a vector. It should be scalar only. Like you
Correct.
mentioned,
Because
0. Yeah, the
Yeah.
0
So
we're
0
finding
is
the
not there.
equation is
I
90%.
should, okay, fine. We'll do that. Basically, it is like this, no? Sine of
Correct. Sin of yes. That will be
0
0
0
here.
into pi by 2.
to 0 is right.
Mm. Yeah.
It's going to be 0 here,
And delta will come before this, sir.
0,
Matrix.
and it's okay. It's okay. I see delta transpose, right? So
Into
let's say this is vector transpose u or u transpose del f, right? Both will have the same value, right? They are
sir,
commutative, right?
but sir, that will be a 2 cross 2 matrix. Now we are finding the scalar part, no, like in one way. This will create a 2 cross 2 matrix.
Which one?
If I put delta after this equation x minus pi by 2 and y, so it will create a 2 cross 2 matrix, no? But
How
we are
come?
finding scalars because this one is 2 cross 1. The other one must be 1
Right,
cross
like
2.
this.
So the product will be 2 cross 2.
Now also.
So the product will be 2 cross 2. No? It will not be a scalar or an equation. It will be a matrix.
Will be 2 cross 2.
Delta comes before that.
Sorry.
Delta f and then x minus pi by
So
2
delta
and y.
will come before, no, sir?
Yeah.
That's what.
Delta
That's
transpose
I'll
actually.
change that. Okay. Yeah, sorry. It should be yeah. Other way around is fine, or I can, okay. Maybe I'll do one thing. I'll just make slide change here. So it will be 0 plus. Yeah, you can think of like this.
0 pi
That is
by
it.
2.
And that is my linear approximation, right? So this is going to be around xy. It is what is that equation then? 0
Pi by
into
2 y.
Y into pi by 2.
pi by 2 y. So L of xy. Now this is my linear approximation around this point 0 pi by 2. But the question is I wanted to find it out at pi by 2 plus 0.1 and 0.1. Correct? Now that means I need to find it out at x equal to
That x is anyway not there, so 0.1 into pi by 2.
L of, I'll write it down there. So pi by 2 plus zero point 0.1 comma zero point 0.1. Basically it is, but it is a function of y only. So pi by 2 into y is
0.
0.1. So this is x point and this is y point. Sorry. So this is zero point 0.1 times pi by 2 or 0.05 times pi. 0.05 into 3.14. Now you calculate the value for this to give your answer. Is that okay? Fine.
Yes, sir.
Okay. So shall we conclude the session now?
Yeah, hi sir. Good evening, sir.
Yeah. Hi.
Sir, do we know like what will be the weightage of each week on like the number of questions, like from which week we can expect
Okay.
the highest questions?
Okay. Maybe I'll just let you know. Is it not discussed in the previous session?
Yeah, I think I missed that maybe.
Is my screen visible to you?
No, sir.
No, sir.
That's good.
That's good.
Okay. So, so your regression is where the best fit line is in which week?
Mm-hmm. So your screen is not visible, I guess.
I'm not sending. I'm actually
Okay.
I'm not.
Okay. Okay. Yeah.
So around like you can say that 20% of the marks will be from week 5. Okay.
Okay.
Then I think if you wanted to see for week 1, right? Week 1 and 2. If I say
Mm-hmm.
combinedly week 1 and 2, it will be around 40%. Like week 1 and 2 combined, I'll say that 40% from week 1 and 2. Week 5
Okay.
will be 20%. And if you just think about
40
week 4,
remaining.
yeah, week 4, right? So I'll say that week 4 will be, yeah, week 3 or week 4 will be around like 30%. And I think 10%. So you can think of like 4 5 will be remaining 40%. And the important
Okay.
topics you will have to understand is like how to find out the column spaces, null spaces of a matrix, right?
Mm-hmm.
Fitting of the line, the best fit line, you will have to find out the equations. So I think somebody else was doing the mistake, right? That you'll have to use that A transpose A X, that formula you'll have to use.
Mm-hmm.
You should know about conjugate matrices, Hermitian matrices,
Mm-hmm.
uh, nullity of the matrix, rank of the matrix, diagonalizability of the matrix, uh,
Mm-hmm.
how to find out the eigenvalues and eigenvectors of matrix, given matrix, right? That also
Okay.
is an important thing to do. Fine. Again, how to find out the basis of the matrix, and I
Okay.
think linear approximation and all of this are there. These are the
Okay.
important topics. So diagonalization is the important topic. Null, finding out the null space of the matrix, column space of a matrix, that is important, right? Finding
Mm-hmm.
out the eigenvalues and eigenvectors of a matrix, that is important. Whether the matrix is diagonalizable or not, and how to find out the diagonal matrix from there, right? So that equation A is equals to S lambda, right?
Mm-hmm.
Where A is your matrix and S is your what matrix of number of independent eigenvectors. That you
Okay.
should know how to do that. You should know the linear approximation method. You should know the best fit line. The best fit line is, I think I have discussed that problem today.
Yeah. Okay.
Given the data, you'll have to find out the best fit line for that matrix. So that x hat you will have to find out the approximate solution that will give you the best fit line, and from that best fit line, how to find out the error of the matrix. All of those are the important questions. Like, these are the topics you can say that the questions will be there definitely on those
Okay.
topics.
Okay.
What I said.
Okay, sir. Yeah. Thanks a lot. Yeah. Thanks a lot. Okay.
Okay. Good night. All the best for tomorrow's exam.
Okay. Thank you, sir. Yeah.
Thank you, sir.